afternoon. Now today we will start the chapter mechanics. It is one of the major part of physics and entire class 11 covers the mechanics as its part. Mechanics, the branch of physics which deals with the bodies in the condition of motion. Is termed as mechanics. That means in mechanics we will study about the nature of motion of a body. Now according to the mechanism of motion of a body, mechanics is further classified into three categories. First is statics, second is dynamics, and third is kinematics. We'll just go for the introduction of these topics because these things already we have done in junior classes. Statics. Here we discuss about the condition of rest of a body, because rest also play a vital role on the motion of a body, because if the body is in the condition of rest, then how much force is applied to make it move. Just like to move a body of mass 1 gram and to move a body of mass 1 kg, we don't require equal amount of force. So that means how much force is also required to bring a body in the condition of rest is also essential for us, because by that only we will design our braking system. So statics deals with the condition of rest of a body, deals with the condition of rest. Now we'll move to dynamics. It is the part of mechanics which deals with the study of motion of a body considering the cause of it. That means why the body is moving, that we will consider in dynamics. Means force is the fundamental factor on it. Force is fundamental factor on it. Dynamics. Now the third part is the kinematics. It is the part of mechanics which deals with the motion of a body without considering the cause of it. That means why the body is moving we will not consider, but how the body is moving, that we will consider in kinematics. So here the nature of motion is the fundamental part. So we have statics, dynamics and kinematics. Now mechanics deals with the motion of a body. So the two fundamental quantities which we have to discuss, first is the condition of rest and condition of motion. What is rest? When a body does not change its position with respect to time or surrounding, then it is said to be at rest. These things we have done in junior classes. Let I keep the marker here and I am not applying any type of force on it. It is at the condition of rest. The mountains, the trees, the hills, all are at the condition of rest because their position are not changing with respect to time and surrounding. Next is motion. You can say the opposite of rest is motion. When a body changes its position with respect to time and surrounding, then the body is in the motion. A bird is flying, moving vehicles on the road, the celestial motion of the bodies, all are in motion. So motion is opposite of rest. Here the body's condition is changing or position is changing with respect to time or surrounding. Now one more vital point is there, that rest and motion, this motion and rest are relative. That means we can't say a body at absolute rate or body at absolute motion. Two persons sitting on a moving train are in rest with each other because they are in rest, their position is not changing with respect to each other, but at the same time these two persons are in motion with somebody watching the train from outside. Because the train is moving and the person is standing here or sitting here, he will see the train is moving. That means the person within the train are also moving with respect to this person. So rest and motion are relative term. Later on, for derivation, we have to consider this part, because when we will define the frame of reference will help us to calculate the acceleration, the velocity, the momentum, and other physical quantities. Now we'll move to the types of motion. Now types of motion is classified according to the nature of motion of the body and the nature of coordinate of the body. So first we'll go according to nature of motion. That means which part is involved in the motion of the body. Nature of motion. So according to nature of motion, the motion is classified into three categories. One is linear, then after translatory, finally vibratory or oscillatory motion. Linear motion, linear path. The motion of a body in a straight track is termed as linear motion. Suppose one coordinate in a track only a car is moving or a body is moving in this frame, then such type of motion is linear motion. Here some individual part or certain part of the body is in motion, not the entire body is in motion. But in case of translatory motion, the entire body is in motion. A ball is rolling on the surface. Here the ball is rolling, so that means each and every part at a certain instant of time is coming with the contact of motion. That means all part are involved in the motion, and such type of motion are termed as translatory motion. Next is vibratory motion or oscillatory motion. Vibratory motion and oscillatory motion are the to and fro motion of a body with respect to some mean position. Like swing, motion of simple pendulum, here the mean position is defined. Now this motion we have to study in the chapter waves, where SHM, it will play a vital role to express the quantities responsible for motion in vibratory part. Linear and translated motion we will discuss in the two chapters, that is motion in straight line and motion in a plane. Now we will quickly revise all the physical quantities we have read in junior classes to define the motion, or you can say factors affecting motion, factors involving in a motion. So we'll move little faster in this segment. So what are the factors? First is distance. How defined distance? The path length covered by a body is termed as distance. Second is speed. Speed is distance covered per time is termed as speed. Then after we have displacement, that is the vector quantity of the distance. That means in case of displacement we have both the magnitude and direction. The vector quantity of speed is velocity. There the distance covered by a body in a point of time in a particular direction is considered. So please try to recall all the physical quantities whatever you have read in class 9, the momentum, force, energy and other things. We will not go for much more about all those things, because when we will go for the derivation or expression, these things we will discuss in a derivative manner. The first things which we are taking here is the speed and types, that is types of speed. So how many types of speeds are there? We have the average speed, then after relative speed, and finally mean speed. In mathematics the word average and mean are same, but in physics the word average and mean are not same. Relative speed is the speed of one body with respect to other speed. So first of all, we will target this average speed. What is average speed? The total distance covered, the total distance covered by a body in total time taken, is termed as average speed. That means during a motion, if a body has different type of speed at different time interval, then what will be the average speed will be calculated by summing up the total distance with respect to total time taken. So mathematically we can write average speed is total distance by total time taken. So if a body has covered S1, S2, S3 and so up to distance in time T1, T2, T3 and so on, then average speed will be S1 plus S2 plus S3 so up to by T1 plus T2 plus T3 plus so on. So average speed will calculate by summing up all the distances covered during that journey and total time or total individual time taken during that journey. Now move to the next topic, that is relative speed. Relative speed. By the name only we are getting a concept that when we are talking about relative, that means how one is related to the other. So in this case, the speed of one body will be compared with the speed of other. That whether the body is moving faster or whether the body is moving slower. If a body is moving with speed VA means velocity of A, if suppose first body is A and other is moving with speed VB, then we have two cases. If the body are moving in the same direction or if the body is moving in opposite direction. So when the body are moving in the same direction, bodies are moving in the same direction. Bodies are moving in the same direction. So suppose this one is VA and another is VB. So if we define how VB is moving faster than VA, then we will write VBA, that is VB minus VA. In the same case, if you want to write how much VA is lagging with respect to VB, then VAB will be VA minus VB. That means in the same direction, the difference of both the speed will give the relative speed of those two bodies. In the same case, if the direction will be changed, that means opposite direction. When two bodies are moving in opposite direction, that means they are approaching each other. So in case of approaching one body and other body, their distance are getting decreased. So they will approach very quickly. So what we will write on that case, when the bodies are moving in opposite direction, then Same bodies we are taking, but the direction is changed. So it will write VA and there VB. So how the relative speed will be calculated? It's VBA is VB and the direction is opposite. So that means here one more minus we will add, that is minus VA. Now minus minus plus. So what was the conclusion? It's VBA VB plus VA. That means on that case the relative speed will be the sum of the individual speeds. Similarly here also we will put a minus sign and we will sort it out. So it is VA plus VB. Relative speed help us to sort out numerical based on the comparing of two speed in any other frame, but here we are restricted only to one direction. When we will mention the direction, then on a plane we will help the concept of vector. We will do all those things in later on classes, but till then just we are moving on linear speed or motion in a straight path. There the relative speed of two bodies will be the difference of them when they are moving in the same direction, and relative speed will be the sum of them when they are moving in the opposite direction. Now we'll move to the mean speed. Mean speed. Mean speed is slightly different than the average speed. As I told you earlier, in mathematics, mean and average are the same things, but in physics, mean and average, there is a bit of difference. Let's see what is the difference here. If a body covers certain distance, with speed, it is speed v1, v2, v3 and so on in time t1, t2, t3 and so on, then the total distance covered as we are knowing, distance equal to speed into time. So first case is a v1 into t1, second case is a v2 into t2, so it's a v3 into t3 and so on. So total distance covered will be the sum of the product of the individual speed covered by individual distance covered by the body. And what is the total time taken? That is the sum of the time. So total time taken, it's a t1 plus t2 plus t3 up to tn, and is the total number of time. So what will be the mean speed here? Mean speed is again the v1 t1 plus v2 t2 plus v3 t3 so up to vn tn, and here we'll write t1 plus t2 plus t3 so up to tn. Now the question arises here, if this time interval of journey will be same, that means in all cases v1 speed it is taking for time t, v2 speed it is taking for t, and v3 also with the speed of v3 it is moving for time t. So that means this t1, t2, t3 will be replaced by only t. So if time interval, time t1, t2, t3 so up to is equal to t, all times are same. So how the things will change? Then we'll write v1t, v2t plus v3t and so on. And here it's a t plus t plus t up to n terms tn. Now what we are doing, we are taking t as a common here, and there also t we are taking as a common. So it will be the sum of all the terms there, individual times. So what we conclude, the mean speed, it will be v1 plus v2 plus v3 and so on into t by n into t. There n is the total number of time considered. So t cancel. So what the things left with us? It's a v1 plus v2 plus v3 so on by n. So how will define mean speed? Mean speed will be the ratio of the sum of individual speed divided by total number of time. Total number of time considered. So there we have discussed about average speed, relative speed and mean speed. Now two more quantities we will discuss here, but those are based on theoretical purpose. One is the uniform speed and another is the non-uniform speed. Uniform, but the word only it is giving a idea to us that the motion is at a perfect or balanced or a constant ratio. So in that case we can conclude uniform speed. This thing also we have read in class 9, that when a body covers equal distance in equal time interval, then the body possesses uniform speed. Practically it is not true in our general life, because there are certain parameters, certain dissipative force which always stop the speed to get in a constant rate. But for an ideal frame of reference, we study it that uniform speed is the equal distance covered in equal interval of time. So if you plot the position time graph here, that we will discuss in our next class, position time graph, on that the nature of graph will be a straight line. This graph represents uniform speed. That means body is covering equal distance in equal time interval. Next is variable speed. This is the practical case. Variable speed. Variable speed when the distance covered by a body in an unequal time interval, or equal distance covered by a body in non-equal time. So either the distance or speed are not equal here. So it may be in increasing order, or it may be in decreasing order, or it may be in curvical order. So if certainly it is increasing, the nature of graph will this. If it is moving and thereafter it is getting down, it can move like that one, or even if it can move like the zigzag ones. So these all are cases of variable speed where equal distance is covered by the body in unequal time, or unequal distance is covered by the body in equal time. So my humble request to all of you that please you revise this theoretical part, whatever we have read in junior classes of mechanics. From next class we'll go for the derivative purpose of this part. Till then, stay safe, stay home.